Okay, so this is the second video on 4.2. So the limits we've evaluated have been investigating the behavior of the function of as x approaches a numeric value. So as x approaches 2, x approaches 3, so on and so forth. So we can also use limits to investigate the end behavior of the function. So as it goes off to the right or as it goes off to the left, by letting x approach either infinity or negative infinity. So for example, let's look at this limit. So the limit as x approaches infinity of 1 over x squared. So whenever you have this type of limit, it's asking about the behavior of your function as x gets larger and larger. So as x goes on forever off to the right, what is the function doing? So if the limit exists, the function will approach a specific value or number or a horizontal asymptote. If the limit is infinite, then the function will increase or decrease without bounds. So there would be no stopping it. It would just shoot off forever, either up or shoot on forever down. So 1 over x squared, as x gets bigger and bigger and bigger, it's making the fraction smaller and smaller and smaller. So as a fraction gets smaller and smaller, as it starts to decrease, it's getting closer and closer to 0. So the limit is going to equal 0. Thus, it has a horizontal asymptote at 0. So that's the definition of a horizontal asymptote. If the limit as x goes to negative infinity or infinity, if it actually equals a number, that's where you have a horizontal asymptote. So we've got some guidelines that you can use to help you evaluate these things. So let's look at what they are. So if the degree of the numerator is less than the degree of the denominator, then the limit is going to be 0. So if the denominator has the bigger power, the limit's going to go down to 0. If it's backwards, if the numerator has the bigger degree, then the limit is going to be either infinity or negative infinity. One of the two, not both. And if it's this case, if it's one of them, that's really saying that the limit is D&E. It does not exist because it's not approaching a number. So the third case is when the degrees are equal. So if it's a tie, then the limit is the ratio of the leading coefficients. And then just kind of watch out for the signs, your positives and negatives, because sometimes they come into play. Not always, but sometimes they do. All right, so let's go ahead and give this a shot and see how it goes. All right, so the limit as x goes to infinity of 1 over x. The denominator has the bigger degree, so that means the limit is automatically 0. And that's it. So you're done with that one. So part B, limit as x goes to infinity, 3x squared minus 1 over 2x to the third plus x. So if you look at it, the degree of the top is 2. The degree of the denominator is a 3. So the denominator wins, has the bigger degree, so it's automatically 0 again. Kind of like these kind of limits because a lot of times they're fast. You just have to look at it and get a solution. All right. So x is going off to infinity, and with this function, if you notice, the degrees are equal. They're both 3. So if it's a tie, then it's equal to the ratio of the leading coefficients. So the leading coefficient on the top is a 3. Leading coefficient underneath is a 4. So it gives you 3 over 4. Now on D, it's the same function, but we are approaching negative infinity. So let's kind of think about what that means for a moment. That means you're plugging in bigger and bigger negative numbers. So that means on the top, if you cube a negative number, it comes out as a negative. So that'd give you a -3. On the bottom, you have the same type of thing happening. You've got a negative being cubed, so that gives you a negative. Well, a negative over a negative is still a positive. So with this one, you still end up with 3/4. So when the degrees are equal, when it's a tie, it doesn't matter if it approaches either positive infinity or negative, it's still going to give you the same result. All right, so I'm going to stop the video here, and the next one we'll look at ones where that might not happen as much.